Okay, today we will talk about reciprocal function. After this lecture, you will be able to manually draw the reciprocal of a function starting from a normal function. Now we will do the linear one, and next time we will do the quadratic one. So imagine if you have a graph as a line, okay, and m is the slope, how like steep is your line, is it left side or right side. If m is positive, your slope will be like this, and if your m is negative, your slope will go to the other side. And now we will see how we can draw our reciprocal function for this function. For example, we have y is equal to 1x plus 2. The first thing you need to do is write your reciprocal function as j of x is 1 over 1x plus 2. Okay, now I can see that from my reciprocal function I am not allowed to have 0 in the bottom side of my gx. So I need to solve for this to know which are the non-permissible value. So x plus 2 is equal to 0 if x is equal to minus 2. So I'm not allowed to have minus 2 in the bottom side of my gx function, which means the line x is equal to minus 2 is your vertical asymptote. It's like this. This is my vertical asymptote. Now what we need to do, we need to find the point that are not changing from my function. So to do that, you need to set this is equal to this. So if the point does not change from this line to our function, to our reciprocal function, mean that this is equal to this, and we will solve for that. So I will put j of x is equal to my f of x. This is fx. So which means that x plus 2 is equal to 1 over x plus 2. This means that x plus 2 squared is equal to 1. X plus 2 is equal to plus or minus 1. X is equal to plus or minus 1 minus 2. So x is equal minus 1 minus 2 minus 3, or x is equal to 1 minus 2, which is minus 1. So the point that are not changing from this graph that will appear in our reciprocal graph is when x is equal to minus 3 and x is equal to minus 1. So x is equal to minus 1 is here. I will just draw it, and when it's touch my line graph, I will put a point there. So this point will not change, and also x is equal to minus 3. Same thing, I will go and touch my line, and this point will not change. If you want to know the y of this, like what is this point and what is this point, you just substitute minus 1 in this equation and minus 3 in this equation. You will find that are minus 1 and plus 1. Always minus 1 and plus 1. So you have minus 1, you have 1, and you have minus 1. So now I know that my function my reciprocal function pass through this point. So let's find another useful thing that will help us to actually go ahead and draw our function. This will be like what is the horizontal asymptote of my function, which means that when this function can be equal to 0. So the horizontal assumption is when your function equal to 0. I will just come here and put 1 over x plus 2 is equal to 0. And this, I can see that will never equal to 0 because this will never equal to 0. so my function will never equal to 0. So my horizontal assumption will be actually the 0. So this will be my horizontal assumption. So I can directly now see that my function is actually passing to this branch. I know this is my vertical asymptote. I know this is my horizontal asymptote. So same thing, passing here. This is my horizontal asymptote, then my vertical asymptote. I just can go ahead and draw it like this. Okay, perfect. Now let me show you this in reality and how this can be actually modulated. So as you can see, this is exactly the function that we have there, except we have b is 1. So I will put b is 1. No, my slope is 1. This is my slope is 1. And my b was plus 2. So this is 2. This is exactly the function that we have before. So you can see here that we have minus 3 and minus 1 are the point which are not changing, which is minus 1 and minus 3. Okay, and they have minus 1 here and they have plus 1 here. So I have my vertical assumption here and I have my horizontal assumption here, and I go ahead and draw my function from there. You can see, I will show you also that when you change the slope, everything is moving accordingly. And the point, there is always some point that are like that show up in both function, in the original one and its reciprocal function. And same thing, if you change your b, it's same thing, the graph will move forward with the x-axis, but same thing, there is always there is some point that show up in both functions. Let me show you one the opposite way, how to find the original linear graph from the reciprocal function. So we have a function that have this form, and if you can see now, our horizontal asymptote is not 0 anymore. If this is 0, yes, our horizontal asymptote will be this line. But now our horizontal asymptote is k, is any number that is added to the reciprocal function. So for example, we have this function. We know that the vertical asymptote should be in when x is different than 2. So that's my vertical asymptote. So for the horizontal asymptote, you can see that I have plus 2. So I will have one horizontal asymptote at x is equal to 2. I know these 2 points should be part of my original function, which is the linear function. But let me show you how you can find it. So the first thing you need to do, we will take this part of the function fx and we will name it jx is equal x minus 2. Okay, I can see this is a line, so I will just draw it. So is x is equal to 2, that means x minus 2, that means my graph go through the point 2 and minus 2. Okay, so I can go ahead and draw a line which go there. So this is x minus 2. Okay, y is equal to x minus 2. But if you can see in my function f of x is this jx plus 2. So I will create another one, h of x is equal to jx plus 2. So which means h of x is x minus 2 plus 2, which is x. So okay, this is my hx. h of x. Now I satisfy everything regarding my fx. I graph the first part and I graph the first part with the second part, which is my hx. So now I can see that I have a common point here, a common point here, and I can see that the impermissible value is here. Okay, this is a good way to draw any function that have this form. You just take the first part, graph it as a line, okay, and you graph you add the second part when you do a translation of your first line, like how many units to the left or to the right.